That's interesting that this actually returned something that had a 2H. Does nil have a 2H on it? Oh. See, this is why nils are bad. Nil should not have a 2H on it. Hey everyone, this is Baylor, and in this video we're going to make an immutable struct from scratch in Ruby. This is going to be based slightly on ImmutableJS. I don't know if you ever used this before. I highly recommend looking at it though. If you don't know what immutable means, it means it can't be changed. It's immutable. That's my definition. It's immutable. And so basically what it's nice is like it's the same reason why you want to prefer not having nulls if possible, because nulls are evil. I am almost of the opinion, just slightly, that changeable objects are evil. So yeah, I just wanted to show you this. This project does exist. It's actually from Stitch Fix, which is kind of cool. I didn't really look at it. I just wanted to see who had created something like this before. And so, yeah, let's get started. We're going to start from scratch. We're going to make a directory called Immutable Struct. And I just like to always have Git available to me. And we're just going to say we're going to create a project for this. And so what we want to do is have a gem file here. We're going to source our rubygems.org, and we're doing that only so we can have rspec. So we'll bundle, and we are adding the gem rspec. Okay, cool. So if I run this, we have rspec, and it says there's no files found. And so we're going to create two directories. We'll have a lib and a spec directory, and I want to edit spec immutable struct spec.rb. We'll require rspec and just run this file, and everything's working. We're going to just kind of assume that we have a file that's relative to here at lib immutable struct, and we're going to describe immutable struct, do an end. Perfect. And so here's our first exception in our unit test, that we have no file. So let's edit that file, immutable struct.rb. And now we have no constant, so we'll create a class immutable struct. And we're good. Okay, so let's think about how a struct actually works in Ruby. So you create a class, like a struct works like this. You say like person equals Struct.new, and we'll say it has a name and an age, right? And what it's doing here, let's just try this. It mimics a struct, right? So let's try this. We'll stub a constant in rspec, have our person, and we'll say this is Struct.new. And we'll do what we just did, name and age. And what we want is just kind of get a feel for what is a person here. And what I expect to be true, I expect this to be a class. And that's true. Okay. And struct is also a class. But person is not a struct. Actually, that might be true. That is true. Maybe we can say struct is not a person. That feels kind of obvious. I just want to see what this does. Okay, struct is oh, that's a not. Okay, yeah, that's true, right? Person and struct are not the same thing, but they are classes. But if you're not familiar with structs, basically we can just say this. We can have person equals person.new, because we know now that person is a class, and we can assign a name and an age, and we expect person.name to equal Bob. And here we go. No more typing abilities. Wow, lots of typos. Okay, yeah, this test passed. When I run this, I'm always like looking at the bottom of my screen, and it's unfortunate that in the video you can't really see that, because my glasses, they turn my eyes blue and I look like a monster. But besides that, my eyes are constantly going from the line that I'm writing code, and then they go to the bottom and they see green, and I just assume everything's good. unless I don't know what the test is, like if person is not a struct. But what I want to show you here is that when we define this Struct.new like this, it is defining a class that almost acts as if though we had said class person define initialize with a name and an age, and name equals name and age equals age with adder readers name and age. At its core, that's essentially what a struct is when we do this shorthand in Ruby. Now, Ruby's doing a lot more. I'll give an example real quick. If I have person2, you notice that these are identical. We can expect person to equal person2 because when we do that, what Ruby's doing here is it's inspecting all these attributes like name and age and seeing if they're equal to each other. And the class type. Yeah, this video is turned into what is a struct, and that is not the point of this video. But let's get to it now, and I'll try to mark the time in this video. So, yeah. What we want to be able to do is we want to be able to initialize a new class. So we're going to have a context. I always like context in RSpec. So it creates a new class. So we'll stub our constant here. We're going to have a person, and it is going to be an Immutable Struct.new, and we're just going to give it the name attribute. And what we expect here is that person to be a class. Very similar to what happened when we did this with regular structs. And you can see here immediately we get a raw number of arguments. So here's something we could do. We could do an initialize. It has a bunch of attributes. And if we run this, it does not work. And the reason it doesn't work is because, which is interesting, because we are not looking at this person class itself. I actually don't know what person is. It's an instance of it's an object, but it's not a class. And that's because when we call this Struct.new here, we're not creating a class, we're creating an instance of this class. So instead of initialize here, we want to do self.new. And now we get nil because we're not initializing this class, but rather we're overloading the .new method, which is used to initialize or classes in Ruby. And so here what we want to do is just say class.new is our return type. And so now we're getting a new class. And another test might be that we want to make sure that we want person to always equal person, right? We don't want it to, we don't want this to lazily evaluate to a new class every time. Simple stuff here. And what we also want to do, we take in these attributes. We want this to define keyword arguments. So struct in Ruby, when you define it like this, it gives them as just positioned arguments. There is a new thing, this keyword init. I think this came in Ruby 2 something. You know, let's just say it's 2 something, like 2.3 or 2.4 or 2.2 or 2.5 or something. Right? It's in the 2s. I want to make this particular implementation always work like keyword init. It makes things a lot easier for this implementation. I have written this before. I just but I hadn't actually looked at anything before actually doing this. So our initialize. Well, so here's what we're going to do. We're going to have this person class, and it requires attributes as keyword arguments. The thing that Python does better than Ruby here is Python likes to just say quarks. And it's so much faster and easier to say quarks instead of keyword arguments, especially when you can't type very well. But what we want to do here is we want to take this same person. We're going to introduce age as well. And what I want to do is say when I call person.new with no arguments, I want this to raise an error that we have an argument error, and I expect to have missing keywords, name and age. And when we run this, we get nothing, and that's a problem. So when we initialize this class, I'm over here on the left now, we want to define an initializer. And the easiest way I know to do this is to actually do a class eval, and we'll just call it Ruby here. And we want to define an initialize method here. And here, we basically want this syntax. And we want name equals name and age equals age, right? Because when we define these as our attributes here, we want to turn it into this code. So to do the first half here, which is creating our arguments for our method, we want to have our init args. And here what I'm going to do is just say take our attributes, map over these as an attribute, and I want to take this attribute and turn it to a string like this. So this is going to create like this age colon, name colon, and we want to join this with a comma and a space. So here we can now use this init args. Let's take this out, our actual assignment. And so this is working. And I took the assignment out because we're not actually using that, so it seems unfair to have that pre-implemented. So what we've done so far is we are creating a new class when we call Immutable Struct.new. And in addition, we are creating an API that requires keyword arguments that are from our initial implementation here. So what we want to do next is actually assign these values. So we can do that here. It assigns values with readable attributes. I should probably just leave the typos. So we're going to take this person down here as well. Person equals person.new. I'm going to assign them backwards just for the sake of, does it really give us any benefit? I don't know. And I say does it give us benefit because we know here that we're using keyword arguments. I guess potentially, I don't know. It just makes me feel better to know that I'm testing it backwards from my initial assignment. Okay, so what we want to do here is just say expect our person.a or name to equal Bob, and expect our person.age to equal 10. And here we get an undefined method name. So this one's going to be really easy. We just want to define attr_reader for our attributes. And so now what this has done is we're taking these attributes that are already coming in as an array, and we're splatting them back out to attr_reader here. And attr_reader defines a read-only method that will read from an instance variable. So that's why we have the method name here, but it's instead of getting back the value that we're initially assigning, we're getting back nil because we're never assigning that variable. So to just make this work, if I assign name to like foobar, now you can see that we get foobar and we expected Bob. So we just need to do this basically here to make it equal to name. So we'll have our init assigns equal to attrs map, take these attributes, and this is going to be spiral attr equals our attr, and we'll join these together with semicolons. And so now we can actually use our init assigns. Init assigns, and beautiful. I need to take out this like this. Oh, Baylor array. Okay, so what have we done now? Well, this is creating the attribute name with a spiral in front of it equals the attribute name without a spiral. And so it's essentially creating, just because this is really good to have metacode that has comments in it like this. Essentially, we're creating initialize with like name and age, right? And then the next part's going to look like name equals name. So this right hand is going to be this one. And this is defining a brand new instance variable. And then we join it with a semicolon so it equals like this, like so. So that's what we're doing in this, and that allows us to actually fully implement the initialization part of it. So the next side of it, this comes into where I want to make this work like ImmutableJS, is that I want to make it where if I assign a new value here, that I get a brand new instance of this particular class. But before we do that, I want to have a helper method called toH that basically allows me to create a hash from my initial attributes. And so it creates a hash with attributes and values. So I want to remove this duplication. I keep defining the same person constant. So we're just going to do a before, grab this, put it in there, dedent. And now everything still passes. We're just minimizing the amount of code that we're actually writing inside of these tests. That's the same thing. So this allows us to say person equals person.new, age 10 and 5, or 10 with the name of Bob. And I want to be able to say expect person.toH to equal a hash. And I want to have the name of Bob and the age of 10. And we get an error that we have no method toH. So this method's going to look like this. We're going to define a method toH, and it doesn't take any arguments, so we don't need to have like arg here. And what we're going to define here is, I actually don't know how this works. Okay, so watch and just be amazed that this works. I'm going to take these attributes, which are here from our initial, this new method, and I'm going to call each with object. And when we take this, we want to have our initial object like that. So now we run this, it does not give us our hash. I guess maybe we have to use this. This is our attribute. This is our hash. Okay. What did this do? Well, each with object is like reduce. But if you've ever used reduce, like if I put reduce here, it's the same API. But the problem is if I run this, I'm going to get nil, right? You see, you see my mouse? See how it gave us back nil? That's because reduce, when we run it like with this reduce, we have to explicitly return our hash, okay? So now you can see that we get back, and it's actually backwards here. That's great to know. And we're getting this. Let me do it like this so I can just have this. Notice how now we're getting back this hash, and that is this thing. So if we come in here and we say like a equals 1, now we're going to get back a hash with a equals 1. So when we do this, what it would look like is we would say adder, and it's so great that I have done this. Oh, you know what? I do remember how this works. Anyways, what we're doing here is let me just replace these. Hash attribute. Hash attribute. Okay. Note. So here's what we're doing when we do this. We're initializing a new hash. We have an instance of this hash, and this is mutable. We're mutating this object in place, and for each of these attributes we get, because we're working with an array here, we get our adder. So we're just assigning this adder as a symbol because that's what we defined it as here. Notice this is symbols. So if we take this, we're assigning on our hash this attribute, and we're calling send, which is going to call this method from our adder reader. The interesting question is, this is where I was thinking, I don't know how this works, is because I was thinking I was actually accessing the instance variable that we're assigning here, but that is not the case. We're just calling send. It's the equivalent of basically calling, and maybe we should call like public send, just so that we don't ever call private methods, but that's like a whole other can of worms. But what we can do here is when we call reduce, like I said, we have to return our hash. So if we call each with object, we have to swap these, and we don't have to return it anymore. So that's the benefit of using each with object, is we don't have to have the explicit return at the end, which would mean that we could probably one line this like so, but I prefer the longer version. Okay, so we have our initialize method, we have our adder readers, and we also have our toH method. The last part of this is to define our set, and this comes from ImmutableJS. So what we want to do is say it assigns a value by creating a new object. Okay, so what we do, we have our person. It looks the same, except we're going to change the age to 5 this time. And I want to say expect person.age to equal 5. And this is going to be explicit, even though this one probably doesn't even used. We're going to have person2 equals person.set age to 10. I'm going to copy and paste. I expect my person age to equal 5. Really, what I might do is this. We'll assign both of these. I expect our person.toAge to equal a hash, and I'm going to have name as Bob and age as 5. And I expect person2 to have an age of 10, right? Because we're expecting this original person to not be changed. And what I'm also going to do here is just say that, and this is like being overly paranoid about this, I expect my person object ID to be greater than our person2.object.id. Now, here's the interesting question. I actually don't know the answer to this. Why is the second object less than the first? I don't know, but it's the way it works. So here we're getting undefined method set. So we define our method, define method set. It takes in the attribute and the value. There we go. And we're getting back an empty hash. And so this is not returning anything. You know what? I actually don't know what that returned. Line 46, is that the line that failed? Yeah. That's interesting. Anyways, this actually returned. We don't want to do that. We want to do something different. So we want to. Here's what we want to do. We want to initialize a new instance of this new class. Should not have a 2H on it. So we can call here self.class.new. And if we run this, we're going to get an exception that we're missing our keyword arguments. So we can fix that by calling 2H on our current instance. We run that, and now we're getting back the same values that we had before. So we want to take this new hash, and we want to merge it with a adder equals our value. And boom, we are now creating, we have this method. It's defining it creates a new instance of our person class. We're using the hash object that we used before, and we're just merging those attributes across. This is a shallow merge. You have to kind of learn how merge works in Ruby to see this. And I apologize. This code feels kind of funny because it is, it's all abstract. There's actually like no true variables except for these two. And these could be inlined as well if we really wanted to. And now we have no variables throughout the whole thing except what's inside of these blocks here. But anyways, I thought this was interesting. I thought this was interesting to show. And if I do this, I had not noticed this before. We have written 25 lines on the left, and we've written 50 lines on the right. And I think because of that, that we genuinely have basically a 2-to-1 ratio on our unit test, that this video is complete and this code is perfect. So thank you for watching this video. Hope you enjoyed it. If you have any questions or comments, please leave them in the comment section below, and I'll see you next time.